Good afternoon.
Afternoon to you all. Afternoon to you all. It's good having you now. Okay. So if you remember, we discussed part 1 of this topic last week. Friday, am I right? Yes, Friday. And so this is part 2 of this topic. Before I forge ahead, the part 2 precisely concentrates on the second part, which is distributed databases. You remember last week was on what? Parallel, but this time we're looking forward to distributed databases. You can see the outline clearly written, but before we forge ahead, I would like to someone to remind me part of what we discussed that very day. Anything at all before I ask a specific question? Anything you can remember from what we discussed last week? Anybody? Quickly? Anybody? Okay, who can do? Yes.
So we talked about characteristics of parallel architecture.
Okay. Oji Chinecheren, please check your mouthpiece or your earphone to know what's the problem. Because like now, Anna to me, I can hear him loud and clear. He can as well hear me. So maybe the problem is coming from your network, right? So one of the things we discussed last week was characteristics. Yes, with this, I now want to ask, can someone remind me one of the characteristics of parallel database that we discussed? One of the characteristics. Be fast. Of course, everything is within the normal time of class, 40 minutes. Yes, somebody, okay. Yes, go ahead. Sleeping. Okay, Chico want to answer. Yes, go ahead.
The communication cost is small.
I didn't get you. Come again, please.
I said the communication cost is small.
Okay, communicating cost is small. Yeah, for parallel databases. Okay, another one? Any other person from another angle? Yes. Should I choose someone? I'll call on someone. Okay. Yes. Yeah, madam.
So it uses shared nothing, shared memory, shared disk architecture.
Okay. It deals with its own architecture, and the architecture are 3 of them: shared nothing, shared disk, and of course. From this point, having asked these few questions. So, introduction and definition, types of distributed databases, architecture, and significance. All right? Okay, so what are we here for today? We said distributed databases. What's it all about? Now, in the house, at home, of course, we said you are a family. But in this family, right now, because of the condition or the situation in the country right now, in the world, everybody is all staying together. Your mom is in the house, you are in the house, your dad is in the house. Nevertheless, all of you have different functions, and you execute these functions at home there. At this point, you're referring to the former last week or previous lesson, parallel. And this one can be doing a particular thing, and the other, as a mom, can be doing her own function, at the same time without interference. But in this case, what about if your dad resides, let's say, in Lagos, and you are at Abuja, or you are in Port Harcourt, and your dad or your mom is working in Lagos, or any other part of the world? Hello. At this point, your dad will be doing what he's supposed to do as the head of the family, but he's not with you. You are not together. Your mom may be somewhere, but she's still carrying out her job role. You, as the son or the daughter of the house, you are still carrying out your job role, but you are not all in the same location. Is someone with me now? At this point, you are carrying out your functions, you are communicating within each other, but you are not seeing yourself. You are not all tied at the same location. What am I trying to say here? Distributed databases. We are saying here that it's a database in which data is stored across different physical locations. It may be stored in multiple computers located in the same physical location or dispersed over a network of interconnected computers. Like you have your student ICT lab in the school, and you have a network, isn't it? Now, there can be our database can be residing in one particular system, maybe the teacher's system, and of course, all of you can connect to that database. You'll be carrying out a particular function. Maybe I may be in my office. I'll be doing a certain thing, still connected to the database server. Are you here now? And these services or operations that is being carried out is not interfering with each other in any sense. Or the job may be shared. You'll be doing this one, I'll be doing the other one, the other person will be doing a different task, depending on the different architectures of this. So what are we saying here? That this one, the data is stored across different physical locations. In other words, the database, the different systems, different servers at different locations running what? The database. And you can carry out any operation without trouble. Are you with me now? Okay. And mostly this type of database is what? Is ensured through a public network. When I mean public network, maybe like internet, you know, or what do you call it? Company organizational intranet or extranet. You did networking last time, so for sure you have an idea about intranet and extranet. Am I right? All right. So this is about what? The definition or the explanation of this. Okay, the last sentence. Okay, I'm going to talk about that. Okay, he said it improves performance at end user worksite by allowing transactions to be processed on many machines. Yes, like if you remember what we talked about parallel database, in this case now, this one seeks to improve performance at end user worksite by allowing a transaction to be processed on many machines. Now, you have a machine, I have a machine. There's a server attached to your own machine, or you may be connected to the server which I am directly connected to. All right. There might be another side in which a system is working. Now, what are we then saying? You can be doing whatever you are doing. The other person can be working on different machines at the same time without any issue. And this is the essence of distributed databases. A kind of a definition for distributed what? Databases. Okay, quickly. Types of distributed databases. Types of distributed databases. One, we say homogeneous distributed databases. In biology, when you say homogenic, what are we talking about? If you say they share the same DNA, what are we talking about? It means that there's something that is common in their gene, you know, a similarity, all right? And so what are we saying here then? That a homogeneous distributed database has identical software and hardware running all the database. In other words, the same DBMS application is being used in that particular network. Whether you are connected, you are in area B, like Lagos, the server there is running the same DBMS. My own here, I'm running the same DBMS. In Abuja, I'm running the same DBMS. So at this point, we are saying that that is what? A homogeneous distributed database. So you are saying that it enables the same data to be used. Yes. Yes, of course. Yes. Yes. If as well, yes. On the same database, on the same data stored in a database, you can be there working on that same database. I can as well be working on that same database without any, issue, right? In other words, it gives us access to the same data, from different points, right? The computer can be in different locations, like I said, or a close location, but not necessarily in the same kind of common location, like maybe in the same room. All right. It can be maybe like this is a school. You have a school. We have a server here running the student database. Like I made mention of my former office, where I manage and I run all the student database in terms of exams and record, result and everything. You can be at home. You log on to this to see your results. At that point, you are doing something. I can also be accessing your result, maybe doing one thing or the other in that same result. So this is what we are talking about. Okay? All right, so thus, data stored across multiple sites is managed by the same DBMS. So that's about what? Homogeneous type of what? Distributed database. Okay? 2, heterogeneous. We fall back again to biology. Heterogeneous. Hetero is a common word used in different fields. Different, not similar. They are not common, all right? So hetero means that you are running a distributed database, but the servers are running different DBMS. Different what? DBMS. I may be having Oracle as a DBMS in my own system. In maybe in your own location, maybe you have a site and a branch office in Abuja, Port Harcourt, Lagos. That server there will be running a different DBMS. Maybe Apple, maybe Mac OS, all that. Are you getting me now? So what you are saying here is they are not running, or they are running different kinds or types of DBMS application. All right? That's about what? Heterogeneous. So the different computers and operating systems, database applications, or data models may be used at each of the locations. There you have multiple sites, which are what? Independent. They are not depending on me. You are not depending on, you are not relying on me. You can be doing whatever I want to do. My server is not depending on your own. Your own server is not depending on my own. You can do anything you want to do. You access the data. If there happen to be a problem with my own site, you can still go ahead. This is about what? This heterogeneous distributed database. All right? Okay, architecture, quickly. In architecture, first of all, we'll look at client-server architecture. Client-server architecture. Right now, in the school, when you come into your lab, you have like the teacher's system. That teacher.
なんと16個ビリヤードのボールは本来15個それより多いパーフェクトショットプラス1プロでもやらないミラクルショットに挑戦を使ったスネークショット手元にある白玉
system can be likened to a server. And every other system in the lab is what? Is said to be what? The client. And so any service you want to gain, you have to get it from my own server. I manage everything. I control everything. If you need anything, you request from my own system. Are you there? So this is what? A client server kind of what? Distributed system architecture. You have you have as a client, you request for a particular data or operations, and the server will carry out the operations and feed you with the reply. This is about what? Client server. Mother daughter or son relationship, or what? Father, son or daughter relationship, kind of, you know, client server system. So in this case, the server, yes, the server manages the data and the processes or transactions, while the client system only do what? Is responsible for user interface request. Okay, so that is for this. Quickly, the second one is collaborating or collaborative server architecture. When you say collaborate, those of you that are lovers of music, there was one of the music, I think, was it last year, 2 years back, Collabo. That just, they fine-tune that word, and you begin to dance and you do like this, you collabo, and you do all the dancing styles. Simple. What are you talking about now? It was a combination of two ideas, combination of two talents, or three talents or whatever. You just link up yourself. You are good in one thing. The other person is good in this thing. The other person is good. You just bring up all the talent together. You put it, harness it, and then you come up with something very wonderful. This is about what? Collaborating. And so what is it all about? This is a collection of servers designed to run a single query on multiple servers by breaking single query into multiple small queries. And the result, after execution, is sent to the client. You can see the diagram, just like the first one for client server. Now, you are out there, I am here. There's a server with you. I'm having a server here. There's another server, maybe, let's just say Mary Ann is in Lagos, and Oganerona, John, any problem? Okay, just coming in. Just coming in. Let's say Muna is in, is it Ireland? No, Udashu Island. Okay, let's go. Maybe Obasi, Chinagoziem is in Benin. And maybe Ifezue, am I right? Ifezue is in, let's say, Ghana, for example. You are having a system, all of us are, working. But if I'm in need of a particular thing from my own client, I will request for a particular operation, and my server will send this request, will distribute the request, query request to all the servers to distribute it. And then all the servers will take their portions. They go about, carry out the execution, and then they return back the result to one particular server, which is the one I'm connected to. And the server will combine all the executions or the transactions and then give me my result. You see now? So your own is doing something, my own is doing part of it. The other person is doing part of it, like what we call, in economics, what do we call that? Who can remind me? In economics, what do we call that? When you share job functions.
Division of labor.
Good enough. Thank you for being there. This is to tell you that, just being an IT guru is not enough, but you need to be versatile. Okay? All right. So division of labor, they just share it, and within a short time, everything is done, and they return it back to the person who requests for the function. So this is a clear diagram of what? Collaborating or collaborative server architecture, right? And then we move on to the next one, distributed architecture. Middleware architecture. Lastly, middleware. What's it all about? This system needs only one server, which is capable of managing queries and transactions from multiple servers. Very important. Now, if you are in point A, I'm in point B, Anayo is in point C, and all of us, we need to carry out different transactions. It becomes very important when you are running a different DBMS. I am on a different DBMS. Point C is running a different DBMS. There must be a middleman. Are you there now? Something we call API, Application Program Interface. All right? So a middleware architecture does what? Has a system that do what? That is like, it brings the 3 or the 4 or the 5 servers together and do what? Bring them together to be able to work together. You know that if I am an Igbo speaking person, you are Ibira speaking person, maybe like Ihamuna is let's say Tiv. There needs to be an API between the 3 of us to be able to communicate. And that API will be who? Our interpreter. So the middleware is to be in between and then do what? Carry out the various transactions, harness our functions together, all right? So that is about what? Middleware architecture. Middleware architecture. It's in between us to be able to harness our communication, the operations or transactions to be carried out. This is about middleware architecture. Any question briefly before we forge ahead? Any question? I'm checking my time. How many minutes do I have? I didn't check time, but okay. Okay. All right. Okay. Hello. Good people in the house, please make this class interactive, interesting to to be with. Any question? Please do that. Yomi. Yes, go ahead.
Please, what did you say API means again? Please repeat it.
Application Program Interface.
Thank you.
Okay. All right, any other question? Nothing else. So you are saying that you are good to go, that all what we are discussing now is intact. Okay, I think, is that who? I saw somebody just raise up his hand. Yomi, yeah, Yomi was the one that asked. I see, is it Martin? Somebody raised up, I think it should be. The one that raised up hand. Elvis, okay, it's Elvis. Just go back from the Martins, okay.
So I want to say that the API does again.
Okay, I said API is just like a middleman, all right? Like you are, what tribe are you?
Igbo.
Very good. Okay, let's assume that I'm from Spain. In other words, my native language is Spanish, right? And then we need to communicate. What's going to happen?
You need a translator.
You need a translator. Good. And so the translator now will become an interface for us. And that interface, you can be likened to what the middleware or the API, something that connects us and enable us to do what? To carry out our discussion. Okay? Are you okay?
Yes, sir.
All right. Another person? Viovo. Viovo, are you raising up your hand? Viovo. Okay, ne? Are you raising up your hand? Okay, she's not raising up her hand. Okay. No question. Good. All right. Let me take it that everything is warara, according to Wazobia FM. Okay, if that is the case, I'll move on to the next thing for us to discuss, and that may likely be the last part of the discussion for this topic. Significance of parallel and distributed databases. Significance. It means that from this subheading, means that they are common. Their significance or their importance are what? They are common to each other, right? And so it is clearly written here. I want someone to read number 1. Patrick, what do you see in number 1? Can you quickly unmute yourself?
Yeah.
Yeah, number 1. What's in number 1?
Fast response time for
For
queries.
queries, good. Fast response time for queries. Do you understand this now? Do you understand it as an importance or significance?
No.
From what we have discussed, that's what I've been asking. You said nobody seems to ask question that is really demanding. From what we have discussed so far, and we are now saying that distributed databases or even the parallel, one of the significance is what? Fast response time for queries. It means that the various interfaces enables one in carrying out transactions that you can gain quick access to your data or processes being carried out. All right. If you want to travel to I'm sure you are in Delta now. Am I right? Where are you right now?
Port Harcourt.
Port Harcourt. Okay. I thought you've gone to Delta. All right. Now you want to return back to your school. Hello. You want to return back to your school and driving out of your compound and then getting to the express, you discover that everywhere, maybe there are 3 lanes or 2, everywhere is packed up full, what we call hold up. What's going to happen? What's going to happen quickly?
I'll wait.
Okay. It means that there will be what? There will be no easy flow of traffic. You can stay there until thy kingdom come. But if there happen to be like 3 major links to this school and you want to come to the school, approaching the first link, you discover everywhere is tied up. What will you do? You move to the third, the second, or the third. Is it not right? What we are saying here is that because of the different architectures disposed by these different databases, that a user can request for a particular data, can carry out transactions at ease. And then you gain back your answer precisely like request. Let's say, for example, you want to access your exam. I mean, your exam result. Okay? Another person wants to access his or her exam result. Are you there now? Now, if the system is not built in such a way that you can request your own quickly, that's query. Another person can do that, get that done easily without any bottleneck. Now, of course, it will not be easy, but it will be configured in such that you can get your requests done at ease. Easy sharing of data. That's already answered from all my analysis. Then 3, parallel and distributed databases improve availability and reliability of data. In summary, they improve availability and reliability of data. If you can, from point A, log on to server B and pick up the data you want, I can be at point A, carry out a particular transaction that is requested by you. What then are we talking about? And then if my system happen to experience any trouble, it will not affect your own. You can still go ahead and get done what you want. What are we then saying? That it improves availability and reliability. What we say, reliable of data. So these are the significance of these various, databases, parallel and distributed databases. Okay, at this juncture, we quickly move on to this. I will take A, B, C, D. Okay. A, somebody from A is going to answer the first question. The database in which data are stored or processed on loosely coupled sites is known as somebody in A class. Quickly. She's sleeping or what? Network may be the problem. Network is the problem. Someone in A class to quickly give me the answer to this. You want me to call any name? Ndukwe. Ndukwe. I hope you can hear me.
So I'm in B.
You are in B. Okay, I was thinking, okay, you are in B. Yes, you're right. You're right. Okay. Let me search for somebody that is in A. Marianne. Are you hiding yourself? Marianne, just sort for it from the participant stuff. Rene. Marianne, please, I'm waiting for you. Yes.
Sir, I'm in B. I'm in B class.
Please give me the answer now. Okay, don't worry. Now let Steven. Yes. Now let Steven, go ahead. Now let Steven, go ahead. Unmute yourself.
Distributed database.
Okay, what's our question again? That the database. Okay. All right. It's good to go. Thank you for giving me that brilliant answer quickly. I think I should be owing you 1.5 mark. Should that be?
Thank you, sir.
Okay, right. Yes, number two, allowing transactions to be processed on many machines is set to achieve. Okay, there's something omitted. Is set to achieve. Yes, from B class now. Allowing transactions to be processed on many machines is set to achieve. Yeah, somebody quickly. From B class. I want to see hands, not just a hand. Black woman, get ready. Yes, somebody from B class. Nobody saying anything? No hand. I'll pick someone. The network's not allowing me to see them clearly. Okay. 5 minutes. Yeah, B class. Nobody. I'm not even seeing their faces again. Network. Okay, Martins, go ahead. Martins, go ahead. Maybe we'll check through that participants. This I can pick their names. Martins. Yeah, go ahead. You can hear me now. You have not. Number 2.
I'm not hearing you.
But you can hear me now.
What? Okay, I'm hearing small. What do you say?
Question 2.
Number 2. I can't see it.
You can't see my screen?
Yeah.
Why? But you've been seeing all this, why?
Yes,
Number 2 question. Okay, let me read it out. Should I?
Sir.
Let me reserve my energy. Look at it. Swap your screen. What happened? Why are you not seeing it?
Oh, I've seen it.
I don't mind that. Yes,
that's very.
Yeah, quickly. B. Okay, good enough. Yeah, good people. Yes, C.
Okay, thank you for being there. Thank you for coming to our channel. Do make sure you click on the subscribe button to possible get the alerts for uploaded videos. See you. Thank you.